Alright, let's do problem 8.11. So, part A says, prove that if EFGH is a parallelogram, then the diagonals EG and FH bisect each other. So, let's draw our parallelogram. Something like this, and let's copy and paste. Get a nice diagram. Alright. Beautiful. Label the points E, F, G, and H. So, let's show that the diagonals bisect each other. So, let's draw the two diagonals. And they are going to intersect at this point here in the middle called M. And I want to show that M is bisecting EG and HF. So, we can typically show these things with congruent triangles. And since we know we have a parallelogram, we know the opposite sides are parallel. Now, what we can figure out from there is that the angle here, FEG, must be the same as EGH, alternate interior angles. Similarly, we have that EFH and FHG must be the same. And we also know from the previous problem that the sides, the opposite sides, EF and HG, must also be the same. So that gives us angle, side, angle congruence. So, triangle E, F, M is congruent to triangle GHM, and that's angle, side, angle. And the last problem does tell us that the side EF and HG are the same. Something we have proved already. So, that informs us that EM has the same length as MG because they're the corresponding sides. So EM is equivalent to MG because of CP, CT, C. And this implies that M is the midpoint of EG. So that's a little bit of part A done. So to do the next part, we're just going to use the same idea as before. So HEG is going to be the same as EGF, alternate interior angles, and similarly HFG and FHE are also the same. And we know that EH and FG are the same, so we get that triangle EHM is congruent to triangle GFM, again because of angle, side, angle, and therefore we have that HM equals FM because of CPCTC, and that implies M is the midpoint of FH. So that is all of part A. Now we can move on to part B. So part B is asking us, does this work in reverse? So if we have a quadrilateral where the diagonals are bisecting each other, does that imply that WXYZ is a parallelogram? So let's draw another diagram. And see if this turns out to be true or not. We will label the points WXYZ. And let's draw the two diagonals. And say they meet at the point N. And N is going to be our midpoint, so WN and NY are the same, and ZN and NX are the same. Well, this should be pretty easy to identify that we have congruent vertical angles there at W and Z and X and Y. And also we know that the angles at W and X and Z and Y are the same vertical angles. So we have two pairs of congruent triangles. Triangle W and Z must be congruent to triangle W and Z. That would match W Y and X because of side angle side congruence, and this implies that the angle, if we have that these two triangles are the same, that means this angle here is going to be the same as this angle over here. So angle ZWN is congruent to the angle WYX because of CPCTC. And what this implies is that since we have these alternate interior angles are the same, we know that WZ is parallel to XY. I mean, actually from here it's kind of simpler. I could have just said that, well, WZ is the same as XY, and if opposite sides, well, let's just continue from where we left off there. Alright, so the next part would be just to show that triangle WNX is congruent. So WNX, it would be Y and Z, triangle Y and Z. Again, side angle side. And eventually that would show us that we have congruent angles. Our diagram's a little messy, so I'll clear some of it up. That would show us we have congruent angles here and here. So angle XWY is congruent to angle y, or wyz. That's CPCTC. And that means that that means that wx is parallel to zy. And now that we've shown that the opposite sides are parallel, we must have that this figure is a parallelogram by definition. Wx is parallel to zy, wz is parallel to xy. Now, the previous three problems have shown us a lot of the properties of parallelograms. So, it's going to be summarized here. In any parallelogram, ABCD, opposite sides are equal, opposite angles are equal, and the diagonals bisect each other. Those are the three main things that we've proven in the last three problems. So, and it works in the converse. If any of these three are true, if either A is true, it implies B and C are true. And if C is true, it implies A and B are true, etc., etc. So, if you prove one of these three things, you have a parallelogram, and that immediately implies all the other things. And this can be a very useful tool when solving problems.